Sponge city construction for green spaces should follow the principles of economy and applicability, and should be designed based on the actual conditions of regional topography, hydrology, and current runoff. The facilities for rainwater infiltration, retention, storage, purification, utilization, and discharge should be reasonably determined. Sponge design for green spaces should prioritize simple, non-structural, low-cost sponge facilities. Different sponge facilities should align with the overall landscape design and coordinate with the site plan, vertical design, buildings, and roads. The master plan of green space construction should include explanations of the sponge facility designs, clearly indicating the proportion of permeable paving, the scale and location of rainwater storage facilities, vertical design, and related measures. The construction drawing design documents should contain detailed sponge design descriptions, vertical design, and sponge facilities at the entrances of water collection zones in depressed green spaces and at the edges of steep vegetative buffer zones. Measures such as isolating textile layers, planting erosion control vegetation, and timely mulching should be implemented to stabilize soil in the green spaces. For green spaces near polluted roads or parking lots, filtration-type vegetated swales or forebays can be installed before the water collection zones of depressed green spaces. Large sponge city facilities such as wet ponds and rainwater wetlands in urban green spaces must have warning signs and alert systems to ensure safe evacuation during heavy rains. And to prevent accidents, the sponge design for green spaces should meet the following requirements. Overall analysis. Analyze the land types and proportions of green spaces, water bodies, squares, and other areas in the construction region, as well as rainfall characteristics, soil water retention, plant community traits, runoff volume, and pollutant levels. Determine runoff direction, water collection points, and water catchment areas. Estimate the current sponge capacity of green spaces, and set design objectives, including target proportions of green space and water bodies. Index calculation, based on the proportions of the existing construction area, water catchment areas, and impermeable paved areas. Calculate the annual runoff control rate and annual runoff pollution control rate, and determine the gap between current and target control rates. Technology selection and scale determination. Select appropriate sponge city construction techniques, and determine the number and scale of these measures. Calculate the rates of depressed green spaces, pollutant reduction, permeable paving, and green roofs. Design plan. Based on the determined technical measures and calculated facility quantities, conduct overall design and facility layout to form the design plan. Review and optimization. Compare the index to judge if there are any deviations in the calculations or facility quantities. If deviations are found, identify the reasons and make reasonable adjustments. Design implementation. Based on the improved content and scale of the sponge city facilities, carry out technical design and implementation, and set control requirements and measures to ensure proper execution. The scale and technical combination of sponge city facilities should be determined according to the type of green space and the nature of surrounding land use. The suitability of various facilities in the combined system should be in line with the site's soil permeability, groundwater level, terrain slope, and spatial conditions, the primary functions of the various facilities in the combined system should correspond to the planning control objectives. Under the premise of meeting control objectives, the total cost of the facilities in the combined system should be minimized, while also considering their environmental and social benefits. Parks and street green spaces. Spaces should adopt sponge facilities for rainwater infiltration, storage, purification, and utilization, and should meet the following requirements. The design should first meet the ecological, landscape, and recreational functions. The rainwater system design for Sponge City. Construction in park green spaces should comply with the relevant provisions of the Park Design Code, CJJ 48, and should meet the required indicators for annual runoff control and pollution control. For green spaces larger than 2 hectares, the water surface ratio should be no less than 10%. In green spaces with significant runoff pollution, wet ponds or constructed wetlands should be installed, provided the area allows. Rainwater utilization should focus on infiltration and supplementing and landscape water bodies, avoiding expensive purification facilities. Park green spaces with low soil infiltration rates should prioritize storage and reuse facilities, and landscape water bodies within parks can serve as rainwater storage facilities integrated with the landscape design. Plans within low-impact development facilities should be selected based on water conditions and rainwater runoff quality. Native plants with strong tolerance to flooding, drought, and pollution are preferred. Rain gardens, vegetated swales, ecological tree pits, and depressed green spaces should be installed around roads and paved areas in green spaces to absorb rainwater runoff. The site planning and design should comply with the following regulations. The terrain design of green spaces should ensure that the elevation of the catchment area of paved surfaces is higher than that of the depressed green spaces. Rainwater runoff should be collected via surface slopes into filtration or transfer facilities and then directed into the depressed green spaces. If the edges of the roads in the green spaces are level with the green areas and the rainwater contains low levels of pollutants, the rainwater runoff can be directed into the depressed green spaces in a dispersed manner. If the roads are higher than the surrounding green spaces, can be set on the curbstones around the catchment areas. Drainage with openings 20 km to 30 km wide, allowing surface runoff to enter filtration or transfer facilities and then flow into the depressed green spaces. Overflow outlets can be set either within the depressed green spaces or at the junction between the green spaces and the paved areas. The elevation of the overflow outlets should be higher than that of the depressed green spaces but lower than the ground surface to ensure that rainwater exceeding the storage limit of the depressed green spaces is discharged into the drainage system through the overflow outlets. The distance between the bottom of the drainage facilities and the local seasonal high groundwater level should be greater than e-meter to ensure normal infiltration of rainwater. Suitable Sponge City construction facilities and the technical measures for green spaces may include land protection and restoration, permeable paving, depressed green spaces, rain gardens, vegetated swales, wet ponds, surface flow constructed wetlands, and vegetative buffer zones. Land protection and restoration technologies include land protection, soil improvement and topsoil preservation, and terrain modification. Permeable paving should be used for sidewalks, squares, and ground parking lots in green spaces. In newly built green spaces, the permeable paving ratio should not be less than 50%, and in renovated green spaces, the permeable paving ratio should not be less than 30%. Here is a typical structural diagram of depressed green spaces, rain gardens, vegetated swales, wet ponds, surface flow constructed wetlands, and vegetative buffer zones. We will study the structural design of these sponge city facilities in the following chapters.